Jai Hind everyone. My name is Ayushi, Assistant Professor from IT Department. In last lecture, we have discussed machine learning, what is learning, well-defined problems. And in this lecture, we will continue from the last lecture we have discussed. In this particular lecture, we will discuss what are the different types of machine learning techniques, different types of machine learning algorithms we have. But very first thing is that we have to recall what is machine learning. Machine learning, as you all know, is a subset of AI. It is an additional branch of, it is a part of artificial intelligence. What it really does? The task of machine learning is to enable our machine model to process the received input in the form of features or other attributes, process that particular received input, and then generate a proper outcome. What is the outcome? What is the input in this particular reference of machine learning is very important to know. Machine learning is a subset of artificial intelligence that enables our machine model to automatically learn from the received input, or we can say training data, and then improve the performance of the machine from the basis of the patterns that we have received from the training data set, and make predictions with the help of those past experiences that we have received in the form of training data set. Then, what are the different types of machine learning techniques we have? There are 4 different types of machine learning algorithms. First is supervised learning algorithm. Next, unsupervised learning algorithm, semi-supervised learning algorithm, and reinforcement learning algorithm. One by one, we will going to discuss each of them, and from the very starting, we will discuss the supervised learning algorithm. And below each heading, there are the examples, use cases of the each learning algorithm. In supervised learning algorithm, there are the use cases housing price prediction and medical imaging. But before that, it is very important for us to know what is supervised learning algorithm. So, in supervised learning algorithm, the training data provided to the machines work as the supervisor. What is the role of supervisor? What is supervision? As the name suggests, supervised learning algorithm, the training of the machine model is done under the supervision of a supervisor. Here, the supervisor is the labeled data set that we have received as input from our environment, from the outer world, and the patterns and the relationships and the labels of that received training data set works as the supervision here. So, in supervised learning, the training data provided to the machine works as the supervisor that teaches the machine to predict, to deliver, to generate the output correctly. And these generated output, whatever the output we have received from a supervised learning algorithm, will be mapped to the received input, because all the data set that we have received will have respective output from the beginning itself. It applies the same concept like a student which is learning under the supervision of the teacher. So, for every problem, there is a dedicated solution already provided by the supervisor. Here, teacher is the supervisor, problem and its solution, which is already provided by the teacher, acts as the training data set. For example, teacher has provided each and every student with a question bank, and each question bank is having a set of questions with their respective correct output. in order to prepare that particular student for to have proficiency in that particular topic or subject. Correct? So with each question, student, that is our machine, that is we are relating it to a machine model, have a dedicated output, which is for sure is correct because it is already provided by the supervisor or the teacher. What is the main aim behind providing labeled data set, or what is the main aim behind providing a student question with their respective answer? The main goal of the teacher to provide student with the answer, questions with the answer, is to make a student able to answer questions which are not mentioned, which are closely related to the questions already provided or already given to the student. So supervised learning, in supervised learning, the main goal is to train our machine model in such a way that in case in real world it is going to receive some problem or to have some data over which there is no label, no corresponding output has been mapped. So the machine will be able to answer on the basis of the prior experiences it has received already with the help of labeled data set. So what we can say, supervised learning is the type of machine learning in which machines are trained using well-labeled training data. What is well-labeled training data? With each input, we have a corresponding output already mapped, already given to the machine. So machine model has question as well as answer also. So it will going to it will be able to map whether the step or whether the action the machine has taken is correct or not with the help of labeled data set. So again I am repeating that supervised learning helps to train a machine model using a labeled data set on the basis of which machines predict the output. Correct? So what is labeled data set? Input data, where input data, a data set where input data is already mapped, already lined up, already tagged with the correct output. Now we have to discuss this particular diagram. In this particular diagram, as you can see, the first level is for labeled data set. In the first level, we are giving input to our machine model. Labeled data set is comprising of different types of shapes: hexagon, square, triangle, then there is another square. With these shapes, we have also having a set of labels that one of the type of shape is hexagon, one of the type is triangle, one of the type is square. With this particular data set, we are also giving input their respective labels, which is hexagon, which is triangle, and which is square. Then this data set, labeled data set, is fed to our machine model over which it is going to train. Machine model is going to train. And with the help of these labeled data set, when after training, we are going to test our machine model with the help of a test data where we are verifying, where we are checking the performance of the machine model with the help of two images here, two shapes, two different shapes. And these two shapes are not labeled because we are going to test the performance of the machine model. So on the basis of the prior experiences that what are prior experiences that we have discussed in our first lecture also. Prior experiences are the intricate patterns or relationships that we have identified while training the model. So these test data will help us to analyze the performance of the machine. When we test our machine model over these test data, then machine will predict the label, the outcome of these two objects, these two shapes on the basis of the label data set. These first this square shape will be mapped, will be searched in the prior experiences that has been received from received by the machine learning, by the machine model. Then when this object will be mapped to the label data set, then it has been identified by the machine that this is a square. So machine has predicted that this shape is a square. Then again, second object of test data, triangle, will be mapped from the prior experiences that machine has received, and it has been predicted that this particular shape is a triangle. In the same way, machine is successfully able to identify that these two test data are square and triangle respectively. Why so? Only because of the label data set that we have provided in the beginning before the training of the machine model. So, and secondly, the most important thing, why we are using supervised learning algorithm, because the main aim of us is to identify the mapping function with which we have identified, with the help of which we are able to map input variable x with the output variable y. Input variable x and output variable y. In test data, input variables are these and output variables are these. So the process, the pattern, the relationship, what was that? That we will represent with the help of a mapping function. The relation between the input variable and the output variable. I have said earlier that we are provided with a label data set. But what was the relationship between the input and the output which we have labeled in the beginning? That is the mapping function, and our main aim was to extract that mapping function with the help of supervised learning algorithm. Now, why we use and where we use supervised learning algorithm, in what type of situations and what type of problem resolution we should use supervised learning algorithm. As you can say, supervised learning algorithm have already labels. So, where we have to use problems like face recognition, pattern recognition, fingerprint analysis, spam filtering, risk assessment, image classification. Face recognition is like what? Image classification. Suppose we are giving this particular example in itself is image classification, pattern classification, signature analysis. These are the examples, these are the problems where we can use supervised learning algorithm, and it will work effectively also. Now, what are the different types of supervised learning algorithm we have? We should not limit ourselves to just supervised learning. Supervised learning algorithm in itself is classified, is divided into two different types, and for different situations, for different types of outcomes, we use these particular algorithm. First is classification and second is regression. And first we will discuss regression. What is regression? What is the meaning of regression in general life, common life? What is regression according to you? Regression is what? Returning back to a worst state, returning back to a prior state. That is regression, degrading state. We are reverting back, we are going back to our last mental status or financial status or emotional status. That we can relate to regression. Downgrading ourselves is like regression. And in machine learning, what is regression? It is slightly different what we have commonly used in our day-to-day life regression term. In regression, machine learning is a technique for identifying the relationships between two different types of variables. When we train our machine model, there are two different types of variables in supervised learning. First is independent variables, and second is dependent variables. What are dependent variables? What are independent variables? We are going to discuss it later on. But first, we have to discuss the definition of regression. So, it is a technique of supervised learning where we have to identify the relationship between independent variables and dependent variables. Here, independent variables are referred as features or attributes. Features or attributes over which we are going to group or distinguish our data elements. In dependent variables, what will be the class, what will be the label, what will be the performance, what will be the behavior of the machine after receiving those independent variables. So, the ultimate goal of regression algorithm is to identify, is to generate, is to deliver a best fit line or a curve between the data. And how it is possible, how we can perform regression? Initially, when we feed our machine model with a set of training data, suppose we have a huge group, a huge data set with these red dots, with these coordinates. Second step will be, we have plotted all these coordinates over this particular plot is representing independent variables, and y-axis is representing the dependent variable. X-axis is here independent variables, variable or variables, and y-axis is here dependent variables. And we, with the help of regression, we have to identify, we have to extract what is the relationship between independent variable and dependent variable. This is our task in regression. So, for say, we are taking a problem, a medical problem, over which, in which we have to identify the blood pressure level of a patient when a certain dosage of drug has been offered to the patient. What will be the blood pressure level or sugar level? We have to take just one dependent variable. So, we have two components here. First is dosage of drug, and second component, second parameter is blood pressure level. Blood pressure level. These two parameters we have. Now, first thing, very important, is to identify which one is dependent variable and which one is independent variable here. Dosage of drug. Dosage of drug has been offered, is being offered to a patient. And this particular parameter has no dependency over any other parameter. So, dosage of drug is here independent variable. And blood pressure level here is the dependent variable. Why so? Why it is dependent variable? Because blood pressure level is depending upon what dosage, in what quantity we have offered drug or or any particular medicine to a patient. So drug offered, quantity of drug is independent variable, and blood pressure level of patient is dependent variable. So, and we have drawn a straight line, a curve we can say, to identify at what dosage patients are having low blood pressure level and at what dosage we are having high blood pressure level. So all these data points has been grouped or partitioned into two different classes we can say, or two different parts on the basis of on the basis of this particular curve straight line here. Not in all cases we will receive a straight line only. It will depend on how many parameters, how many variables, input variables you have as independent variables, because in the definition you can see there has been mentioned independent variables. There can be one variable and multiple variables also. For example, for a student's performance in exam, the output can be measured with the help of the marks or percentage, in the form of percentage. And the factors affecting the marks of that particular student can be multivariant. For example, sleep he or she has taken prior to the day, a duration of study material he or she has referred, way of writing a solution in exam. There are multiple factors. There can be multiple factors affecting the student's performance in exam. The student's performance in exam is dependent variable, which is depending upon other 3-4 factors. These 3-4 factors collectively is representing with the help of this x-axis independent variables. So in regression, the main goal is to identify the relationship between the independent variable and the dependent variable by just drawing a straight line we can say, or a curve which is partitioning our data set, training data set. Okay, this is regression, and the one or two real life examples I have already discussed with you. 2-3 we can also discuss here also. The first point here mentioned is businesses often use linear regression to understand the relationship between advertising spending and revenue. What is this? What type of example is this? In this example, we are going to say, we have a product for which we are we have to promote our product. Any product you can take our product, and for that for the promotion of that particular product we have spent a huge amount, whatever amount we have spent over advertising, and whether we have spent a least amount, whether we have spent a huge amount of advertising, what is the outcome? The revenue we have received after promoting our product, and and that revenue is the sale of the product after promoting that much, after spending that much amount on advertising. So here in this particular example, advertising spending is independent variable, and revenue is the dependent variable. Now you can identify why revenue is the dependent variable, because revenue is depending on the amount we have spent on advertising, promoting our product. Coming towards the third example, Here the agricultural scientist uses linear regression to measure the effect of fertilizer and water on crop yields. In this particular example, we have two independent variables. Set of independent variables have two parameters, two components. First is effect of fertilizer and water. First is fertilizer and water. These both will be represented over x-axis, and crop yields are the dependent variables which are depending on the effect of fertilizer and product, the quality, what is the quality of fertilizer and how it is helping the yield of crops. Okay. Now coming towards next type of supervised learning. Next type of supervised learning is classification. This is the simplest type of supervised learning, and I am assuming that or you all know a little bit about classification if you have gone through first lecture of machine learning. What is classification? Classifying objects. Classification. This term you have discussed in your junior classes also. When you have to mention, when you have to write different types of anything. Classification is what? To identifying different types of different groups within the given data set. So classifying algorithm is what? It is another supervised learning technique which is used to identify the category of new observations, and these new observations will be derived only from the received training data set in that we have just received. And in classification, the ultimate goal is to train our machine model, and machine model is going to learn with the help of a software only. So in classification, a program learns from the given data set or observations and then classify those data sets or observations into number of groups in which we want to categorize our given data set. For example, you have given as input a set of fruits. You have 5 images of 5 different fruits with you. Suppose 5 or 2, we can say first is apple, next is orange, and third fruit is grapes. This is what? Training data set. And this training data set is labeled, because the key point of using supervised learning is that in training data set we are providing our model with the input with respect to its output also. So it is already mentioned that this is orange, this is orange, this is apple, and this is apple. Grapes. Likely, we have specified, we have labeled all our data. Now, this training data set will be fed to our machine model, and over this particular training data set, our model has been trained. After training our model, now it's turn to test our machine, and we have fed 2 different images of fruits as training data. First is grapes and second is apple. We know that only because we have given them as test data to the machine model. So what will machine do? Machine will one by one, machine will take one input, one test data, and then matches it with the prior experiences or the training data it has received. Then first it took this picture, this image, and one by one it is going to map with each and every image of the fruit. and over which image it got fixated or mapped, it is classified into that particular group. This is what? Classification. Yes, this is classification. Or we can say we have labeled this particular object, this training data set, and we ask our model to generate to give to classify all these objects. The simplest problem in classification that we can give to our machine is to classify, to partition, to group the given data set in on the basis of the properties it is inheriting. Training data set is inheriting. So over this training data set, three groups has been created. First group is for apples, second group has been labeled with orange, and third group has been labeled with grapes. So three classes has been created, and in these classes these 5 fruits will be classified. This is the classification or second technique of supervised learning. Any in case of if you want to discuss any real life cases of machine learning model, so in first lecture I have multiple times referred to the spam filtering, email spam filtering problem. If you want to identify, if you want to classify the received mail as spam or not, so these are the labels. Spam is one label, not spam is another label. So whatever mail you are receiving as input in your input box, it will be classified only in the 2 categories. The answer will be whether the received mail is spam. If it is not spam, if it is not matching the attributes, properties of spam, then it is going to be put in the folder of not spam. If you want to answer in yes or no, or left or right, use 0 or 1. These are the labels: 0 or 1, yes or no, spam or not, fruit or animal. These are the classes which has been already given as label when the machine model is fed with the training data set. These classes are not being generated by the machine itself. Machine has not automatically identified these labels. These labels are already given as label by the supervisor. And who is supervisor? Label training data set is the supervisor itself. Now, what are the advantages of supervised learning? Since I have multiple times told you that in supervised learning we are given with a labeled data set. So with the help of labeled data set, we have an exact idea about how many classes we have to distinguish our objects, and what are the classes also. Number of classes and labels of the classes are already known to us before the model has been trained. So this is the most important advantage of supervised learning. Second is, it is very easy for our machine model to identify, to verify the output generated, because with each input we are already having a correct output mapped. And with the help of prior experiences, past experiences, what are the past experiences? Training data set. In training data set, we have already have input mapped with the correct output. So these algorithms are helpful in predicting the output on the basis of prior experience. Second, disadvantages. If any approach is only having advantages, then there is no need to use its alternate. if we are having multiple types of learning algorithms, supervised, unsupervised, semi-supervised, and reinforcement, then we can say that there are some shortcomings also, which next one or their alternates are uh, recovering, working over. So supervised learning, which is very simple to us, which comes to us as a very simple effective learning algorithm, but it also have some shortcomings, like it is only applicable for very simple problems. It is not able to solve very complex tasks. For example, if we have given some input in test data, and those test data is not closely related or not part of the training data set, then in supervised learning the result will not be accurate. It may predict the wrong output if the test data is different from the training data. This is its shortcoming. Then the time taken to train a machine model with the help of any form of regression or classification is very time consuming. So the computational time taken by our training model is very high in supervised learning. So in complex problem, we avoid usually this particular approach. So this is our supervised learning. Here it is completed, and in the end of this lecture, I'm just comparing regression. I'm comparing regression and classification for you one more time. Take a problem, for example. There is a problem where we are asking students marks. Yeah, we have a, if we are asking students what is the percentage you have received in your last semester, then we have just asked for a value. What is the percentage? And percentage will be given in the form of a value only. That value can be in integer or floating value, but it is going to be a value, approximate value. Approximately, maybe if the percentage of the student is 69.7, it can answer, she or he can answer in 69.7, or this is the accurate result, and the approximate result will be 70%. But in both the form, we are receiving a value only. When we want a value outcome in the form of a value only, not in the form of classes, a value only, then we perform regression. For example, what is the moisture level of the soil? The moisture level of on the basis of the moisture level of the soil, humidity is measured. So here, moisture level of the soil is independent variable and humidity is depending on the moisture level. So humidity is the dependent variable, and on the basis of moisture level and humidity, we are receiving a particular value. Humidity is of that particular level. What is the today's temperature? Today's temperature is suppose 12 degree. 12 degree is a value. So here we are referring as regression. Here regression takes place, where we are asking for a value, regress. And if we are categorizing what will be the weather, hot or cold, humid, sunny, what will be the weather tomorrow, sunny or rainy, hot or cold. These are the classes: hot, cold, sunny, rainy. So our result will be in the form of a class only, not in the form of any value. So here we are working over the labels of the classes, titles, not on exact value. So here is classification. Hopefully you have thoroughly enjoyed this lecture. Today we are ending our lecture here only with supervised learning, and in the next lecture we will discuss unsupervised learning, semi-supervised and reinforcement learning. Thank you.